Hi everyone, my name is Hannah, and these are my group mates Erik and Dale. Before we start, let us explore this map to see all of our topics. As you can see, we have 8 topics to explore for this episode: minerals and rocks, exogenic processes, endogenic processes, rocks under stress, evidence of continental drift, movement of plates, relative and absolute dating, and last, the geologic timescale. Let's start.
Dale, how can rock-forming minerals be identified using their chemical and physical properties?
Minerals and rocks are one of the most valuable materials known to man. It provides the landscapes and materials that are essential for us and is known to be the building blocks of the world. So what are these resources? Well, minerals are a natural substance that is represented by a chemical formula, which is a solid and inorganic. Many rocks came from minerals that are called rock-forming minerals, which is a combination of common minerals. There are many physical properties of minerals that are used to identify them. These are colors, crystal forms, hardness, luster, cleavage or fracture, streak, and specific gravity. Rocks are composed of one or more minerals but are not crystallized, and they do not have chemical formulas like minerals do. They are, however, made by specific types of minerals, but rocks also have physical properties like color, shapes, lusters, textures, and patterns. Geologists identify rocks on how they are formed and are classified as igneous, metamorphic, and sedimentary.
Dale, how are sedimentary rocks formed?
Sedimentary rocks are formed by the consolidation of elements that settled out of water, ice, or air and are gathered on Earth's surface. It can be spotted on land or underwater. When they are composed of individual mineral or rock particles obtained from weathering, they are called clastic or detrital sedimentary rocks. When they are originated from chemical precipitation or from the biogenic action of organisms, they are non-clastic sedimentary rocks. But when they are formed from the accumulation of plants or animals' debris, they are called organic sedimentary rocks.
Dale, how are igneous rocks formed?
They are formed when magma cools off, forming crystals. They are characterized by an interlocking crystalline texture. They can be formed below or above the Earth's surface and can be classified in various ways. Intrusive igneous rocks. They are formed when magma solidifies within the crust below the surface. These types of rocks crystallize below the Earth's surface and form large crystals when cooled slowly. Extrusive igneous rocks. They are formed when magma erupts to the surface as the lava flows, and it usually cools very quickly.
How are metamorphic rocks formed?
They are formed through the process of metamorphism, or the change in form of pre-existing rocks. The original rocks or protoliths is subjected to heat and pressure, which cause physical, chemical, and mineralogical changes to the rock. Protoliths may be igneous, sedimentary, or pre-existing metamorphic rocks. They are also formed within the Earth's crust, and the change of temperature and pressure changes to the mineral assemblage of the protolith. Metamorphic rocks are eventually exposed at the surface by uplift and erosion of the overlying rock. There are 2 kinds of metamorphic rocks: pileated and non-pileated metamorphic rocks. Pileated metamorphic rocks have layered or banded appearance produced by exposure to heat and directed pressure, while non-pileated metamorphic rocks do not.
Hannah, how do rocks behave under different types of stress?
So we've talked about how rocks are made or formed, but how do they behave in certain situations where stress is being implied? Well, there are 3 types of stress that can alter the form of rocks and land. These types of stress are compression, tension, and shear. Compressional stress is when rocks are compressed or pushed together, resulting in the rocks to break. Tensional stress is when rocks are pulled apart. The rocks then either break or lengthen. Shear stress. Shear stress is when rocks slide past each other in different directions that causes the rocks to break. What is continental drift? Well, continental drift theory was proposed by Alfred Wegener. He hypothesized that the continents were moving or drifting away slowly. He came up with the continental drift theory, which states that one time that the Earth had one giant supercontinent called Pangaea. Wegener came up with this idea because he noticed that the coasts of the Western Africa and Eastern South America looked like puzzle pieces, which might have once fit together and then drifted apart. Looking at all of the continents, he theorized that they had once been joined together as a supercontinent called Pangaea.
So Hannah, what are the lines of evidence of continental drift theory?
To answer that question, Wegener's theory of continental drift was not accepted for many years. Why? For one, Wegener did not have a convincing explanation for the cause of the drifting. He suggested that the continents were moving around due to the Earth's rotation, which later turned out to be wrong. Secondly, he was a meteorologist, someone who studies weather, not a geologist, so geologists didn't think he knew what he was talking about. But there are also lines of evidence that support plate movement. Jigsaw fit. The continents look like they could fit together much like puzzle pieces that have drifted apart. The similarity in the outline of coastlines of Eastern South America and West Africa had been noted for some time. The continents fit together like pieces of a puzzle. This is how they look over 250 million years ago, a supercontinent called Pangaea. Second would be fossil evidence. Fossils of similar types of plants and animals in rocks of a similar age have been found on the shores of different continents, suggesting that the continents were once joined. For example, fossils of Mesosaurus, a freshwater reptile, have been found in both Brazil and Western Africa. Also, fossils of land reptile Listosaurus have been found in rocks of the same age in Africa, India, and Antarctica. Evidence from rocks. When the geology of Eastern South America and West Africa was mapped, it revealed that ancient rock outcrops, or cratons, over 2,000 million years old, were continuous from one continent to another. These rock outcrops are a result of mountains. These mountains were probably once parts of a mountain range that broke when the continents separated. Evidence from climate change. Coal forms in warm and swampy climates, yet large coal deposits have been found in Antarctica. Limestone deposits from coral reefs that form in tropical climates have been discovered in the northern United States, which is far from the equator. Groves and rocks deposits left by ancient glaciers are found today on different continents very close to the equator. This would indicate that the glaciers either formed in the middle of the ocean and or covered most of the earth. Today, glaciers only form on land and nearer to the poles. The most likely explanation for the location of these deposits is that the continents have drifted apart. As the continents drifted, they passed different climatic zones: polar, temperate, and tropical. The fifth one would be evidence from magnetic polarity. Magnetite crystals in fresh volcanic rocks point to the current magnetic North Pole no matter what continent or where the continent the rocks are located. Older rocks that are the same age are located to the same continent point to the same location, but that location is not the current North Magnetic Pole. Older rocks that are of different age do not point to the same locations or to the current magnetic North Pole. In other words, although the magnetite crystals were pointed to the magnetic North Pole, the location of the pole seemed to wander. These are some of the final pieces of the puzzle that led to the development of modern plate tectonic theory. Since its emergence is in 1960s, plate tectonics theory was gained widespread acceptance as the model of Earth's process.
Hannah, what are the different results of the movement plates?
Well, firstly, there are three types of movement in plates: divergent, convergent, and transform. Each of these plates' movements give different results like divergent. A divergent boundary occurs when two tectonic plates move away from each other, creating earthquakes, rivers, mountains, and ocean ridges. Convergent. A convergent boundary occurs when two or more tectonic plates move toward each other, creating volcanoes and mountains. Transform. A transform boundary occurs when two plates slide past each other, creating rivers, ridges, valleys, and land displacement.
Wait, Eric, I have a question. How does the age of stratified rocks identified?
Well, stratified rocks are identified by relative and absolute dating. Relative dating is done by doing the following. First, principle of superposition. Younger rocks form on top of older ones. Second, principle of original horizontally. Sometimes the strata is tilted, so geologists must carefully study the strata to figure out which layers will lay down first. Third, principle of fossil succession. Strata that contains fossils of the same types must be approximately the same age. 4. Principle of inclusions. When one rock is enclosed within another, the enclosed rock should be older. 5th, principle of cross-cutting relationships. Anything that cuts through a rock must be younger than a rock that cuts through. 6. Principle of unconformity. A clear break between rock layers is called an unconformity. The rocks just below the unconformity formed millions of years before the rock just above it. And while relative dating is based on comparison with the other rocks, absolute dating is done by doing, first, radiometric dating. This method is based on the careful study of radioactive decay into other isotopes. Radioactivity always changes atoms in a steady, predictable way based on their unique decay rates. Different elements are used for dating different age ranges, like these ones. For example, carbon-14 to nitrogen-14, which are radiocarbon. These atoms can be found in organic remains and archaeological artifacts that can date up to 60,000 years ago. Secondly, age bracketing. To look for clues to determine the minimum and maximum possible ages of a sedimentary rock layer and of any fossils within that layer.
Erik, how are guide fossils used to define and identify subdivisions of the geologic timescale?
Guide fossils are used to define geological periods. These fossils can be defined as commonly found, widely distributed fossils that are limited in time span. If one finds a guide fossil in a given layer, then one has connections with that age of that layer. Using guide fossils, the geological periods are defined, like this ones for example. The Ilrathia is found in the Cambrian period, meaning every fossil that has the same level of Ilrathia can be in the same period of it, which is from 490 to 540 million years ago.
Wait, so one last question. How can the Earth's history be interpreted by the geologic timescale?
The geological timescale is a tool used to portray the history of Earth. It has relative dating, which is interpreted by periods, apex, and age. In periods, there are apex, and in apex, there are ages. Thank you so much for listening until the end. I hope you enjoyed and learned the topics that we have discussed today. Bye-bye.